Alex, let me change one thing about yours, just placement of the negative. But other than that, it's fine.
Oh, so it does matter.
Yes. So either up front or out front or in the numerator.
Okay.
That's okay? So you could have done this one of two ways. Either looked at your graph and counted your slope and found your y-intercept, or did it algebraically. You have your 2 points. You can count, do your slope algebraically, and then either look and see where your y-intercept is, or find that algebraically as well. Questions on that first one? So you are not supposed to do B, but does anyone want to come do 2A? Okay. So I'm going to do this algebraically, and then I'm going to show you how you could use Desmos to do this. So we talked about this before, that you have to use your point slope formula. Because you have a point, you have a slope. So you would write this as y minus 3 equals our slope of 1/2 times x minus negative 4. If you immediately put it as positive 4, that's fine. And then we would distribute. So y minus 3 equals 1/2 x plus 2, and then get rid of your 3 by adding it to the other side. So y equals 1/2 x plus 5 should have been your final answer. Who all got that? Good. In Desmos, if you wanted to see this, and I'll recommend that you practice this later. If I type in y equals mx plus b, it will, in lowercase letters, it'll have you add sliders, so add all. You know what the slope was, it was given to you, you know it's 1/2, so you can change that. We don't know what our b is, but we know it goes through the point, what was that point? 4, 3, negative 4, 3, what was the point? So I'm going to plot that point, label it. Then it kind of becomes a guessing game. So we need to adjust this or move it to somewhere so that this line goes through this. So if you figured out what the answer is, don't say that answer, but guess a different number. Guess some answer for B. 3, okay. So if I put in 3 here, it's getting closer. Line is not quite there yet. So maybe 4. Okay, closer, not there yet, so maybe 5. And that could help you. I would say if you wanted to practice using Desmos, look back at our last set of notes where we were writing the equation giving slope and a point, and do this and see if you can figure that out. And plus you have the right answer, so you can go back and check, is this the right one? The only thing about this is you have to know this information, like you have to know to type it in, add the sliders, change your slope, and then play around with the b. You also have to know, because it asks you to write the equation, how to find that from the graph. So Desmos only helps you so much with some of these things, so just keep that in mind. Anyone want to do number 4? So with this example, it says something about a vertical line, so you should immediately be thinking Poivox. Vertical line, Poivox. Horizontal line, Poivox. Then it says it goes through this point. So if it's a vertical line, is that X or is that Y? x, this is vertical line, x equals. Then you need to find which of these will be your x value in your order pair. Alex, 4. So you know it's a vertical line, it's supposed to be an x equals, the x value is 4. Put all of that together, you get x equals 4. So that's really information you need to know in order to solve a problem like that. Right? I will show you how you could use Desmos. It is basically the same as what I just did, but in graph form. So if I were to plot the point that they gave us, 4, 5, and I know it has to be a horizontal line, I could do one or two things. So I'm sorry, a vertical line. I can put in x equals 4 and y equals 5. Okay, I was like, they both did that. And see which is the line I need. Now, the only confusing part of about that is you would need to know which one you're looking for. Are you looking for the red line or the black line? If you mix up your numbers, though, then it won't go through the point at all, and that might confuse you more. So you'd have to keep your values straight and know which type of equation you're looking for. So keep that in mind. Okay, questions on that last one? So you guys all have this big packet on your desk. This is another SOL review packet. This is something that you are going to work through up through May. So I'm going to assign a standard or multiple standards depending on how many questions there are. And then I'll give you like a week to do so. So today, I'm assigning all of SOL A1. So that's numbers 1 through 17. And that will be due next Friday. So you have a week to get that done, whether you do that in your free time, when you have time after class, with me before or after school, is up to you. I would say use Desmos if you can. You can do it by hand, algebraically. Either or does not matter. You just need to be able to do all of this. We will go over all of those questions on Friday, next Friday. And then next Friday, I will assign you another standard or standards to do for the following week. And it'll keep going like that. It'll either be due on a Thursday or due on a Friday. In Canvas, I will put in assignments to match these so you know when they're due also. If you want to see those or view those, they'll be in the SOL module, SOL review module. So hold on to this. Do not lose it. I do have some extras, but I don't want to make 22 copies of this again because we're losing it. So make sure you're holding on to this. Questions on that? If you use your course calendar and want to write those dates and standards on there as we keep going, you can also do that. Great. I know we don't have a whole lot of time. So really quickly, we'll go through just a couple of these. Last class, you did this investigation, and then you were supposed to answer these questions before class ended. So now my question is, I'm just going to ask you the same thing. What did you notice about the slopes of each pair? What did you write? Your groups wrote down. What did you find? Nathan? The slopes are the same. Okay. anyone else say something different? Lily? Okay. So is that specifically about the slopes or is that about the line in general? Yeah. So that's more so for the line, but this one is just talking about the slope. But the slope helps it do that. Right. What about the y-intercepts? What did we notice? What did you write for that answer, or what did you see, or if you didn't get to that, what do you see now? If you're comparing those equations. Think about that, and then we'll answer that question when we get back from the equations. What do you notice about those y-intercepts? Major? Okay. So the y-intercepts are different. Anyone have anything other than that? So if we had to put a general statement to that, like combine 4 and 5, 4 parallel lines, what would we say? If you answered that already, what did you already write down? Not really the X, but the M, yes. So, parallel lines have the same, and I'm going to adjust that a little bit, M or slope values, and different B or y-intercept values. That's a good general statement for all parallel lines. So if you didn't write that down or have both of those things, you can write mine down. Then we're going to answer these questions. For this number 1, are those parallel to each other? Based on our general statement? Yes, yes. Why? Or how do we know that? And same slope and what else? Different B values, yes. So because of both of those things, they are parallel. If only one of those things happened, they would not be parallel. So like, if they had the same slope and the same y-intercept, they would not be parallel lines. They'd be the exact same line. If they had different y-intercepts but not the same slope, they would not be parallel. Right, so keep that in mind. For number 2, are these parallel to each other? No, why? So even though the y-intercepts are different, the slopes are not the same. So this is no. Then 3 and 4, you had to come up with 3 lines or 3 equations that were parallel to the one given, y equals 2x minus 3. Give me one. Major. Okay. Y equals 2x plus 6 works. Give me another, Cameron. 2x plus 3, that would work since the y-intercepts are different. And then Lily, you have one.
1 equals 2
be different. It could have been 400, as long as it's different. Right? Now give me 3 lines that are not parallel. So y equals 5x minus 2. Victoria?
Y equals 5x minus 2.
Okay. That would not be parallel because it's the exact same nature.
Y equals 5x
Not be parallel because they have different slopes. And then one more. Camera down. Also not parallel because the slope is not the same. Okay. Now we're going to switch gears. So we talked a lot about parallel last class and today. Now we're going to talk about perpendicular. So on the next page, I've given you blue, purple, and orange. If you have your own colored pencils, feel free to do that. Just focus on doing the graph for right now. I'm going to give you 3 minutes to do the graph. And then if you finish before the timer goes off, then you can start the math of the next part. I'm going to show you what it should look like. If you're still finishing, that's fine. Just make sure you look and see so you know yours match. So the purple line should look like this. Your blue line should go down here. And your orange should go through there. Remember that I have highlighted the ones that were already there. On the next page, just like the parallel, you are going to find the equations of those 3 lines, the blue, the purple, and the orange. Whether you do that algebraically or look at the graph and count, your slope and y-intercept is up to you. I'm going to leave these points up here so that you can, if you're doing it algebraically, you can write them down. But I'm going to give you 5 to 6 minutes to do the 3 equations on the next page. The equations that I'm going to show them. Okay. And then remember, you could have done this algebraically or counted it from the graph. The blue equation was y equals negative 3 over 2x plus 2. The purple was y equals positive 1/3 x plus 7. And then the orange y equals 5 over 2x minus 10. So make sure you have those written down. Before we answer these questions, we need to talk about kind of what perpendicular means. So I'll go back to this page if you still need this. Does anyone know what perpendicular lines look like on a graph? Yes, they do intersect, but it's not just that, because if they intersect at all, those would just be intersecting lines. They have to be intersecting at a specific place. Intersecting so that they make a T, not really an X, because that would just be intersecting, but more like a T. So like the blue line doesn't really do that with C, because it's not really making a T. It's not really doing that with A, because that's not really a T. So it has to be doing that with B. There it makes like that T. So the blue line and B would be perpendicular. What other 2 lines would be perpendicular? Or what is perpendicular to C? What makes that T? The purple. So there I see that T. So then that means that A and orange are also making that T. So you can fill out the rest of those. Orange and A, blue and B, purple and C. Once you have those all written down, you're going to go ahead and answer the questions on the back of this page. I would say have your paper open like this so that you can see the equations and see the questions at the same time and you're not flipping back and forth. Okay, so I'm going to give you now, when we are talking about perpendicular lines, or the ones we just found, what did we notice about the slopes? Okay, that's not always the case, but I'll put that. Hannah, the flip, Victoria, what were you going to say? Were you going to say the same thing? Okay, so they're flipped and they have opposite signs. So the fractions is that was just our specific examples. Could happen, could not happen, but they usually are both flipped. They usually both have opposite signs. And then what did we notice about the y-intercepts? Do you see anything that stands out about the y-intercepts? You sure? They're all different, okay. But really, if they were the same, it wouldn't matter. So they could be different, they can be the same, it doesn't matter. And again, that depends on if they're the same, if they're different, but it doesn't matter for the y-intercept. So how could we mix those things together and make a general statement for perpendicular lines? Think about the one we made for parallel lines. It'll be similar. What do we think? What could we say in general about all perpendicular lines? That'll be a mixture of the things we just said. So how could we mix all that together to talk about perpendicular lines? What do we say about the slopes? Okay, and? Okay. So that would be part of it. And then what do we say about the y-intercepts? So let's put all of that together. Perpendicular lines have fill in the rest. How would we fill out the rest of that? Christian, what do you think? what do we know about the slopes? What do we know about the y-intercept? We're just writing that in one big sentence.
The slopes are flipped in half the sides, and it doesn't matter about the y-intercept.
Flip and opposite sign slopes. And the y-intercept don't matter. Not this. So if we had to generalize it for all perpendicular lines, that would work. So are these first two perpendicular or not? Dakota, you said no. Why not?
Because slopes are the same.
Okay. So these would be what instead?
One would be negative and
If we were making it perpendicular, yes. What are these as is?
parallel.
Parallel, yeah. So these are not perpendicular. What about the second two? Yes. Cameron, why? Or how do we know? But not just that they're flipped. What else? They have opposite signs. So it has to have both, otherwise it's not perpendicular. So just like parallel, if the fractions were flipped but the signs weren't opposite, it would not be perpendicular. Or if the signs were opposite but the fractions weren't flipped, it would not be perpendicular. Give me 3 lines that are perpendicular to y equals 2x minus 3. Give me one. The example we said was perpendicular. How would we make this one perpendicular? I'm going to help them out. What would that slope be, Sophia? Negative 1/2. Can you give me the rest? Make up one. Whatever number you want. Your favorite number. That works. Alright, give me another. Iman, make sure you put your phone back up. Lily, are you raising your hand? Yeah. Okay. You need one more that is perpendicular. Sophia. Even though all of the lines we just found are parallel to each other, they're perpendicular to the original. Alright, now give me 3 lines that are not perpendicular to y equals 5x minus 2. Cameron? They're exactly the same. That will not work. Lily, and then nature. 5x. Okay. Again, they're the same, so not perpendicular. Nature. Again, this. You could have also said negative 5x plus or minus whatever. You could have said 1/5 x plus or minus whatever, because those would still not be perpendicular. They didn't do both things. Okay, so that was like the basics of parallel and perpendicular lines, so you could figure out how they work. I don't want to use too much time because I need to at least start the notes today. We need to at least start the notes today. But on your desk you have a set of cards for one word. I want you to match parallel and perpendicular lines together. So there are two types of things. One is a graph, one is an equation. The equations go together, the graphs go together. The equations and graphs do not go together. So keep that in mind. There are 8 sets of perpendicular things and 7 sets of parallel. I want you to match as many as you can, and then you can tape blue staple on your gold sheet. If you need more gold sheets, let me know. You can use the front, the back. You can put all parallel on one side, perpendicular on the other, mix and match, doesn't matter. I would say you could work together parallel and perpendicular lines and what they're used for, the basics. Now we're going to actually get into what we would use them for. So I want you to write down these definitions on the notes I just passed out. I know I gave you a lot today. Make sure you hold on to this stuff for the binder check. I did not get this. So the graphically definition is for parallel lines are lines that never intersect. So we talked about that when we were trying to figure out which lines would be parallel. The algebraic definition of that is that they have the same slope. You can also add in and different y-intercepts. This symbol off to the side, you'll see a lot in geometry. But that means parallel lines. Then for perpendicular lines, the graphic definition are lines that intersect at a 90-degree angle so that it kind of makes like that T. That's what we were talking about. You'll learn more about angles and geometry. Algebraically, they have negative or opposite reciprocal slopes, and we'll talk about that definition here in a second. And then this upside down T is how we is the symbol for perpendicular lines. And then I'm going to throw up one more definition up here. Negative reciprocals are a fraction that's been flipped and the sign is switched. So if it was 1/3, now it's 3, or if it's 3, it's now 1/3. But if it was negative, now it's positive, and vice versa. Once everyone has all these definitions written down, we're going to do one example and then stop for today, because I know we've been working really hard today. Anyone still need these definitions? If I missed your hand, I can come back. Alright, so first let's do, this is not the example I'm talking about, we're actually doing one of these, but if I said, what is the negative reciprocal of 3/4? What would you say? We can say it out loud. Negative 4/3. The negative reciprocal of 2, negative 1/2. Negative reciprocal of negative 7/8. 8/7, positive 8/7. What about of 1? Negative 1. And then you may have seen it when we were doing the matching. Do we know what the negative reciprocal of 0 is? It is undefined. It's weird because you don't really think about it as it being negative. So it is undefined. I'm going to show you why. So if I have some 0 over 1 and I flip it and make it negative, well, anything over 0 is still undefined. So 0 and undefined, you have to know that those are negative reciprocals. Those are perpendicular lines, or would be perpendicular lines. Okay, so let's do this first example and be done with today. So we have to determine, are these sets of lines or ordered pairs parallel, perpendicular, or neither? How would we find that from the ordered pairs? What would we need to do first? Bless you. Find the slope. So let's find the slope of both of these. If you need more space, you can write it off to the side. So I'm going to write my slope formula first. M equals y2 minus y1 over x2 minus x1. Then we're going to find the slope of both AB and CD. If you want to label them, you can do that. So for AB, we'd have 6 minus 3 over 2 minus a negative 2. What would that slope be? Camera. And then let's do the other one, CD. Same thing, if you want to label them, you do that. So now we have 3 minus 0 over 3 minus negative 1. What would that slope be? 3/4 again. So are these parallel, perpendicular, or neither? Parallel. So you can either write that they're parallel or use the symbol. Either one. So then next class we're going to do a couple more of these examples. I'll have you try some, then we'll move on to something else. So make sure you hold on to this, don't lose it. I know we went through a lot of this fast, so if any of this did not make sense, please come see me before or after school. You guys can put your calculators away.